He's called it Thor because it has a hammer. So you can see it moving around playing croquet. So there's a number of modes that this operates in. So initially, what you're going to see here is manual control using Bluetooth in real time. So the robot here has a Lego Next controller. Do come in if you want. Has a Lego Next controller which is communicating via Bluetooth to this, which has software on it that can control the motors on each side. So there's a motor at the bottom here on both sides that controls the caterpillar track, so we can rotate, move forward and backward. There's also a motor here that can rotate like that, and that controls the hammer. So you have to position the robot close enough to the ball, whack it with the hammer, and off it goes. So you can see how when students have been spending their time, they can become quite good at this sort of thing. So let me just move this on a bit. Has anyone played croquet before? Know the idea of the game? Okay, so basically it's a bit like snooker. So you try and get balls through hoops and so on. Let me just pause it there, because what you saw there was the robot would get into a corner and the student bounced it off the back of it and therefore solved that problem. That is an example of human intelligence solving a problem, a previously unseen problem. Okay, the ball's there, the robot can't get in, we'll whack it and bounce it off against. AI finds it very difficult to do things like that. And one of the things that would be interesting in doing this project is seeing how much we can get artificial intelligences to learn how to solve these problems previously unseen that they come across. Even working out how to get balls through hoops would be good. So the idea of the croquet game anyway is that you try and get the ball around the hoop, but you have an opponent who's also trying to do the same thing. But you can get extra shots for playing good strokes. So if you get through a hoop, you get another shot. If you hit your opponent's ball, you get another 2 shots. So you can actually build up complex breaks and actually move around quite far. You're not going to see anything like that happen today, I have to say. So let's move this on a little bit. So here we see the going through hoops. So you can then get an extra shot for that. So there's a few action shots of that happening. This again is all just human control through the Bluetooth. Now, it's skipped onto the AI mode thing here, so I'll just pause it there. So what the student also did was he's built a representation of this world in software. So we have a board, we have robots that can move around, we've implemented the physics of the balls moving along, friction against the bays, and collisions, so we can detect balls going through hoops, we can detect collisions, and we've also imposed on that all the rules of croquet, so you're not allowed to knock over the hoops. If you get through a hoop, you get another shot. If you rotate somebody else's ball, hit in somebody else's ball, you get 2 extra shots, and so on. So on this platform, we've got all the rules of croquet implemented. So we can actually use this software in order to ultimately train robots to solve problems. So we have a very simple AI implemented. It's not really an AI, it's a scripted player, so it's completely predictable, completely specified in terms of what it does. So the robot player on here, or the computer player, all it does is says, what's the next hoop I'm trying to go through? And then it aims to put the ball through that hoop. That's all it does. And that's actually quite hard to play against, because it's working in this nice environment where everything is very clean and predictable. It works. It's quite an effective strategy. Of course, in this environment, things aren't predictable at all. So what's happening in the real environment here is that we're using a camera to work out where things are. So the camera has to work out where all the hoops are, where the balls are, where the robots are. That then connects through a wireless network to this computer, which then processes the image, which you'll see shortly, and tries to work out where everything is. And then the AI on here has to then say, okay, well, what am I going to do with that knowledge to try and achieve my objectives? So if we move it on a little bit, So what you'll see now is the robot, the real robot, acting in AI mode. So it's analysing the image and it's deciding what to do. So the first thing that's happening here is just, it's saying, okay, I know the next hoop I've got to go through, I know where the ball is, and it moves itself to get through. This is it trying to avoid obstacles, so it's now moving on to take its next shot, but it's got to get around the hoop. Oops, it's knocked into it a little bit there. So that's basically what we're trying to do. So there are all sorts of projects that we're hoping to run now in terms of improving the analysis of where things are, improving the AI of the robots, and so on. So I'll now show you the system itself in operation. So what you're seeing here now is the current image. So this is what the camera is currently seeing. I have to say it took me about an hour to set this camera up yesterday to get a decent enough image. So slight movements of the camera, you're not seeing the whole board. You can see, you can't see the image on the screen yet. Let me just sort that out. Somebody give me a shout when you can see it. Is it there?
Almost.
Almost? Not at all.
You can see.
You can see it? Yeah. Excellent. Yeah, it usually takes a few goes. Okay, so now you're seeing what the camera sees. So you've just got this plain duty image, and you can see there's some distortion around the edges. So as soon as things start going here, it's quite difficult to work out what the distances are. And down here in this little panel here is the robot software. So you probably can't read that from where you're sitting, but what it's doing is just allowing you to set up the game. And it's saying, do you want computer players or do you want human players? I'm just going to go for human players here. Which is going to be one of the announcements. So I now start the game, and what you're seeing now on the screen is the virtual world that the robot is using to work out where everything is. Now at the moment, it's got two balls and a robot in it, so it hasn't done anything to match up what it's actually seeing through the camera. So the first thing I do is, without the robot and the balls on, I work out where all the hoops are, because they've just been placed manually. So I'd say place hoops and peg, and what it then does is it goes through the image and it's looking for, it knows what shape these things are, so it's looking for edges, and it knows that there are 6 hoops and a peg to find. So it's analysing the image and saying, applying various operations to the image to try and filter out what looks like a hoop and what looks like a peg. So if I press that, depending on the light conditions, it should find the hoops. There we are. So it's found all the hoops and the peg, no problem at all. Now the robots and the balls on there are still in just sort of default positions. So the next thing it's got to do is find them. So let me put them on. Roll the black ball up there somewhere, put the white ball nicely in front of my hoop, and then we'll stick the robot on, let's say there. Now, what are we trying to do here? Well, the balls are quite easy to detect because they are circles. The only problem you have with the white ball is if it's a bit close to one of these hoops, it's hard for the camera to tell it apart from the hoop. The robot's a bit harder. Clearly the robot's a big thing, so you can sort of say, okay, there's a robot there, but working out what way the robot's facing and where the hammer is and that sort of thing, that's a little more difficult, and actually it doesn't currently work very well. So let's try and find the robots. It's essentially looking for 4 points. It's looking for the white ball, the black ball, it's looking for the robot, and it's looking for the end of the hammer. So those are the 4 points of the text. Right, place robot and balls, go. Yes, now you quite often get this message, can you find them? So if you can read that, it says image processing should return a total of 4 extremis, or 4 points. So sometimes we'll just run it again so you can find it this time. There you are. So it's actually found where they are. So we now know where the robot and the balls are, and we can start to play. Would anyone like a go at moving the robot? Okay, I'll do it. It's very embarrassing, that's why I wanted somebody else to do it. Okay, I'll have a go. So we can control the robot, it's just linked to the the arrow keys on the keyboard, so I can rotate the robot like that. And I can move it. Now, the software here is actually trying to enforce all the rules of the game. So if it thinks I'm going to bump into something, it actually will stop the robot from moving. So if it suddenly stops and I'm not able to move, that's the reason. And of course, you've really got to try and match up the virtual world very precisely with the real world. So that's a problem that on this short project I haven't really been trying to do very successfully yet. You can see I'm a lot less practiced at it than my students. Maybe just a bit there. Okay, and let's see if we can get through the hoop. Oh, no. Now this is interesting because what you'll see has happened is as turns go, of course, we want repeatedly to say, well, where are the robots and the balls now? So if I now look for the robot and the balls, it'll have great difficulty seeing that because we've got right next to the hoop and we've got the hammer sticking over the end. So if I now say, try and place robot and balls, it will be unable to do so. There you are, see robot and balls. So this tells you quite a lot about the difficulties of AIs. We've all seen Terminator and that sort of thing. That's really, really hard to do. We have got millions of sensors, and we are trained to do things from an early age. You're born and you can move around and knock things over and hit your face with your hand, that sort of thing. That's all a learning process, and over time you become very, very able to do things. If I threw a ball to you now, you'd have a good chance of catching it. But you've never been in that situation before. You've never been sitting in the corner of the room with me throwing a ball of unknown weight across to you, but you'll probably catch it, because we're very good at learning by examples and then very rapidly matching